Yes, I definitely have more hair back then. Yeah, I got the great. Yeah, it was from a nail. I have a what? Yes, I do. Okay, let's get started. We need to do ellipses. Go, gadget ellipses. Write equations that will allow you to graph the following ellipses on your calculator. Come on in, Miss Nelson. All right, okay, so ellipses, if we graph them, true or false, they are a function. False, why? They don't pass the vertical line test. And on your calculator, if you go to graph something, right now it only allows you to graph it in form of a function. So really what we have to do is we have to write an equation for the top and an equation for the bottom. And we're going to do that by solving for y. So in this problem right now, you can do a number of ways. I'm going to multiply through by 100. Why am I doing that? Because there's a 4 and 25, it will get rid of the fractions in the denominator. So I have 25 x squared plus 4y squared is equal to 100. Subtract the 25x squared, or y squared equals 100 minus 25x squared. Then what? Divide your 4 and square root. Y squared equals 100 minus 25x squared over 4. Square root. When you square root a variable, you need to have a positive and a negative. And so all I did was solve for y. And all I'm doing that is because it says write equations that will allow you to graph the function or the following ellipses on your calculator. Now that I have that, I can type in two functions, the positive one and the negative one. And if I do, I should see, hopefully, both parts of the ellipse. So you may say, well, I can't really graph them. You can get a general idea to see if you've done it correctly. Let's try that. You may. So I've got 100, double parentheses. Whoop. Forgot a parenthesis in there. Okay, so I'm going to graph these now, and when I graph them, you can see it does the bottom, and it does the top. Why do I have that gap in the middle? Your calculator can't generate a lot of values that are right on top of each other because then it would cease to be a function. So in terms of how your calculator generates data, and there'd be a lot of points right there that would have evaluated at 2. And just the way that the pixels are and everything, it can't really do a whole lot. So if you were to zoom in, it would change it a little bit, but that's just the way it is. There are other ways to graph things. If you press mode on your calculator, you can tell that right now it's set to graph in function mode. But there are 3 other modes you can use. Later on in this class, we'll learn about parametric mode. So you can submit an x equation and a y equation in terms of the variable t. That's actually kind of interesting. You can also graph in polar form. Polar form you just give a radius value actually, and then use theta as a degree measure to graph stuff. So there's all sorts of ways we could graph stuff. We're not limited to just the functions. You can actually use those measures in order to graph an ellipse. We don't know how yet. Okay? We don't know how. We haven't gone through all the trigonometry. But sometime we will. If I asked you to solve that on your own for y, could you do it? Yeah, I mean, that's not hard. So let's skip it. Let's go on to something more interesting. It says, write an equation for the following ellipses that could satisfy the following conditions. So what we want to do is we need an equation, and we're going to assume that these are all centered at 0, 0. But an equation is going to be of the form x squared over a squared plus y squared over b squared is equal to 1. And note that a squared could be under the y squared or the x squared. Just depends on how it's stretched. That's what we have to figure out. Well, it says the focus is 0, -4, plus or minus 4, and the vertices are 0, plus or minus 5. And really what we need to do is we need to identify A, B, and C values. If I were to sketch a graph of this, (0, -5 and 0, +5 are the vertices. And 0, +4 and 0, -4 are the focus points. So you tell me, is this ellipse stretched vertically or horizontally? It's stretched more vertically. How do you know that? Yeah, they're on the y-axis. You have your vertices and the foci are on the y-axis. So therefore, the a squared is going to go under the y squared, not under the x squared. Now, if the distance from the center to the focus point is 4, what is your C value? 4. Right? C is the number of units from the center to the foci. And A is the number of units from the center to the vertices. What's that distance going to be? Do you know how far this is stretched horizontally? Could we find out? What do we use? Good. C squared equals A squared minus B squared. C squared is 16. A squared is 25 minus B squared. -9 equals -B squared. 9 equals B squared. So B is equal to 3. So this would be stretched out 3 units in the horizontal direction. Now I know exactly what it would look like. But my goal is to write an equation. Now that I have A and B, can I write an equation? I have x squared, y squared. It's going to be equal to 1. A squared is 25. Does it go under x or y? It goes under y because it's stretched vertically. B squared is 9. Goes under the x squared. That's my equation. So I just wrote an equation for an ellipse. I had to do some, kind of problem solving, do some kind of puzzle work and figure out where I'm going. That makes sense? Any questions on that? So that's all you got to do. You just got to come up with that. Okay, let's try one more. Endpoints of plus or minus 2 square roots of 2, 0 on the minor axis. The minor axis, not the major, and a distance of 10 between the foci. If there's a distance of 10 between the foci, what's going to be your C value? 5. And if you have a tough time sorting through this information, go ahead and draw it out. So endpoints of plus or minus 2 square roots of 2. 2 square roots of 2 is going to be approximately 2.8. So, that's on the minor axis. So the major axis is going to be vertical or horizontal? Vertical. So we're looking for the endpoints here. Well, we know that the foci, I'll put those in green, are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How would I find Well, do I know A or B right now? B. B is 2 square roots of 2. Because that's the minor axis. How would I find A? Good. So if I square C, I get 25. A squared, we don't know. B squared, 2 square roots of 2 squared is 8. Add the 8, I get 33. So A is the square root of 33. So I'm going to write my equation. So it looks like A squared is 33 and B squared is 8. Which one does the 33 go underneath? The Y. Because the minor axis is along the X. So the 8 goes underneath here. Any questions on that? See how I kind of problem solved that, figured that out? Okay, we're going to do one more problem, and I think you're going to have room on your paper to do it, but the issue is that my pre-calculus class last year, Danny, question. So our equation says that you have A squared and B squared. So A is the square root of 33, so we got to square that. Okay. But instead of doing a whole lesson or 2 or 3 on section 9.4, they said just sprinkle in a couple problems in with this and it'll be easier. So I want to do one example where the center of the ellipse is not at 0, 0. Question. Oh, the equation I wrote down? What I should have done is written down that equation, and I should have also written down this one. You could choose either or. In both situations, we chose that one because it was stretched more vertically than it was horizontally. Does that make sense? That's a good question. Okay, this is an extra example. I want you to write this problem down, because this is what you're going to have from 9.4. So we have x minus 2 quantity squared over 25 plus y plus 3 quantity squared is equal to 1. This is in the shape of an ellipse. And we want to find all the characteristics of this ellipse. And in order to do so, I'm really going to have to identify A, B, and C. Once I find those, I can then identify the center, the vertices, the major axis length, the minor axis length, the foci, and the eccentricity value. So those are all the characteristics that we're going to identify for an ellipse. Let's start with the center, since that's what's changed here. How much is this shifted? 2 in the x direction, -3 in the y direction. The center is 2, -3. You can see just from how we've worked with parabolas and from how we've worked with circles, your center is going to be 2, -3. So all that stuff you did in Algebra 2 last year about transforming functions, that's what's happened here. We've transformed this graph, and we moved the center from 0, 0 to 2, -3. Any questions? Oh, I got 2, -3. Okay, then the rest we just go from there. What's your A value? 5. B value? Good. It's divided by 1, and the square root of 1 is 1. The C value, I would have to take A squared minus B squared. What's 25 minus 1? Square root of 24. 2 square roots of 6. This is approximately 4.9. So now we have all the important characteristics. Before or these parts that could tell me the characteristics, let's draw the graph, and once we get the graph, then let's label it. And again, I don't think I did quite as good of a job teaching this last year. We maybe just went to listing out the characteristics. I'm telling you, draw a picture, and then from the picture, write down what you know about it. So we're going to draw our picture, and I'm going to do an 8 by 8. So the center is 2, -3. Over 2, down 3. If I'm going to draw this, what should I do now? The A. So I use 5, and I go 5 units. Which direction? Horizontal, both ways. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. It looks like those are my vertices then. And that would bring me to a coordinate of -3, -3, and of +7, -3. So after I've actually gone in each direction, I can then list what my vertices are. So I just look at my drawing. So what's going to be the length of the major axis then? What's the distance between those 2 points? 10. Minor axis, how many units do I go in each direction from the center for the minor axis? I just go 1. Now I have a shape of my ellipse. So the length of the minor axis is 2. The foci will be 4.9 units in the direction that it's stretched. So if I go 4.9 onto 2, I get 6.9, -3. And if I go the other direction, I get -2.9, -3. So if I just go in each direction from there, I'm going to end up just, about a 1/10 short from each spot. Before I do eccentricity, any questions how I got those 4? Or 5? 1, 2, 3, 4, 5. Okay, what's the equation that we have for eccentricity? C divided by A. And the C value in this case is approximately 4.9. I divide that by the A value, which is 5. And if you do that, you get about 0.98. And the closer you are to 1, the more it represents a line. So this is a pretty flat ellipse, pretty squished ellipse. And that's that. So you can see it's not that hard to apply the transformation, right? You just do it, then you draw out the graph, see what you get. Okay. Here's what I want you to do. It looks like you have 2 assignments, but you really don't. Okay? These are the shifted ones. So hopefully last night you were able to get through the basic ones. Now you do the shifted ones, and then these are ones where you write equations. So that's what you have. I really wanted to test next week Friday, but we won't make it. So because we didn't have class on Tuesday or on Monday. Tuesday was basically a half day. Friday's can basically be a half day, right? So, but I want to try to get through this section as quickly as possible because it's not as important as the rest of the trigonometry is. So, and two, I'm going to tell you guys, this is a test. There could be, out of a class of 54 or 58, there could be 25, 30 perfect scores. I'm not kidding. There was a ton last year on this test. You guys could get perfect scores on this test. You could know this stuff that well. Because you get it, right? I'm gonna give you the information. I'm gonna give you the formulas. I'm not just gonna make you memorize them all. So, okay.